Yeah, so backspace compare, given two strings s and t, return true if they are both equal when both are typed into empty text editors, means a backspace character. Note that after backspacing an empty text, the text will continue empty. Okay, so given two strings, so s equals ab hashtag c, ad hashtag c for t, and it reflects true because if you were to start at the end, c equals c, hashtag, hashtag, you skip over or delete the next character, backspace it, and then you end up with A and A, and they're the same. They're the same. And then for here, because there's two backspaces, they essentially backspace the first two characters, and then you both end up with an empty string. Okay. And then this one isn't because there's no, you only backspace the first character, so it becomes C, and then T becomes B, and those are not equivalent. Okay. So what needs to happen here, I think, um, would be one approach that I think we could do. Oh, and I missed one thing down here. It says, can you solve it in linear time and constant space? Right, because if you if you didn't, yeah, I mean I think if you were to go with a two-pointer approach, you would start at the very end character. Um, Start at the end with two pointers, one for JS and one for T. Go iterate down to the last character, to the, oh, I guess would be the first character. Process backspaces. If at any point you run out of backspaces, or the characters are not equivalent, you can return, or I guess you would say, and the characters are not, you can return true, or sorry, false. If the characters are equivalent, you keep going down. You keep going down until you reach the very end. And if no characters and return true unless you have uh, run out of backspaces uh, and have non-equivalent characters. So the very first thing we're going to do is instantiate these two pointers. So len, or sorry, s t I and j equals len s minus 1, len t minus 1, and what you'll do is you also need to keep track of the backspaces because in the case of like example 2, you're kind of banking the backspace because you're skipping over B, but you're also going to skip over A, or yeah, backspace A and B because you have two in a row. So you keep track of that. Back S and back T equals 0, 0. And then we're going to do this continuously because we're going to shuffle it all the way down to the end. So while true, we're going to use some nested operations to nested while loops to process the backspace. While I is greater than or equal to 0, meaning that there's still characters left. And back S is greater than 0, or S of I equals hashtag, which represents, okay, we have some backspacing to do. You're going to lower decrement I, or you're going to or you decrement I, and you may have to adjust the count of back S. So if there is, if it is a hashtag, you're going to plus equals 1 if S of I, if it's actually a hashtag, else -1, meaning that, you know, you run out of it and you need to go down. So I minus equals 1. So and then we're going to do the same thing for the J, and back T is greater than 0, or T of J equals hashtag. Back T minus or plus equals 1 if T of J equals hashtag. Else -1. Yeah, and then J minus equals 1. All right, now we've processed the backspaces for the moment. So we set like an end condition. So if I, and any of these could trigger an end condition. So if I is less than 0, or J is less than 0, there's no more characters, or S of I after processing the backspaces isn't T of J, you know, like if you were to hit -1, -1 in the parlance would be the last character, or yeah, as part of the Python syntax, like S of -1 would go to its last character, so we know that we've reached the end. We've reached the end, and now it's like gonna point to the beginning. So like this can happen. We're gonna add a condition that says like, okay, we're evaluating whether or not we've actually reached the end, and whether or not those characters are equivalent. So return I equals J equals -1. And in that case, if we haven't hit this end condition, then we just keep going. I minus 1, J minus 1, and then we can do some testing to see how correct this is. So in the very first example, we're using AB hashtag C for S and AD hashtag C for T. So that means I and J are going to be equal to 3 and 3. Back S and back T are 0 each, while I is greater than 0, it is, and back S is greater than 0, it is not. So we skip over the nested while loops. If I is less than 0, which is not, or J is less than 0, which is not, or S of I doesn't equal T of J, which that condition isn't hit either because they're both C, we just go down. We decrement I and J. So now we're at I and J equals 2 and 2. And at this point, we have a hashtag. So I and J are 2 and 2. And that means while they're both over 0, and now the back S isn't greater than 0, but the S of I and T of J are hashtag, we get back S and back T are now 1 while it goes down. So I and J are now at 1, 1, 1. And then they're both still over 0 on line 14 and 17. Back S is now over 0, as is back T. And so we do have to process it again. So back S is now, and back T are now 0 because they're adding -1, because the character at S of 1 is no longer a hashtag. And then I and J are now equal to 0 and 0. Okay, now we're at the end, we're at the first string. So if I is less than 0 and j is less than 0, nope, they aren't. So we go back around and then and we decrement it, I and j. So I and j is now -1, -1. So back s and t are still 0, are now 0. Now, is I greater than or equal to 0? No. Is j greater than or equal to 0? No. So we skip the nested while loops, and now we're at the end. If I is less than 0, yes. Return I equals j equals -1, and you get true. So this should return true, and that's what we would expect. And so this is a solve, and as far as the complexity, there should be constant space because we're only maintaining the position of the pointer, so it doesn't matter how big the data set is. We're always going to have only one or only the pointers that we use for like the same number of pointers, no matter what size data set n. And then the space complexity, we're iterating over each element a maximum of once, so that should be the requirement of linear time.